Welcome back, everybody. Mr. Reniker here again. In today's lesson, we are going to start learning how to read and write values in scientific notation. And your main objectives are going to be to define scientific notation and then read and write values in scientific notation as well. Let's go ahead and get started with the first key idea. It says that a number is written in what we call scientific notation when it is represented as a product of a factor and a power of 10. Now, you have to keep in mind that that factor has to be greater than or equal to 1 and less than 10. So 1 itself can be used, but it has to be less than 10, so 9.9, 9.8, and so on here. So we see in our example, it says the factor is greater than or equal to 1 and less than 10. 8.3, somewhere between 1 and 10. And then the power of 10, it has to actually be an integer here. So keep in mind that an integer, that is any positive or negative whole number. So we couldn't have a power of 1/2 or something along those lines. So in our first example here, we're just going to identify numbers that are written or are not written in scientific notation. So we're going to need to remember those two key aspects to it being in scientific notation. So it says tell whether it's written in scientific notation. In other words, these should be yes or no questions in a way. So the first thing we'll pay attention to is the factor itself. Is that number greater than or equal to 1? And is it also less than 10? And of course, the answer here is yes, 5.9 meets those requirements, so that's a check. And then when we look at the power of 10, we have to make sure that the exponent is an integer. And if that is true, and of course, yes, it is, -6 is an integer, then we say that absolutely yes, this is a number written in scientific notation. And then when we look at part B here, we test for the same thing. We look at the factor first and ask ourselves the same things. Is it greater than or equal to 1 and less than 10? But this time we have to say no. Definitely not. 0.9 is not greater than or equal to 1. It's less than. Now, while the power of 10 is okay, I mean, that part's great. The exponent of 8 is an integer. Since the first factor did not meet this, this is no, not written in scientific notation. Now, sometimes what we'll need to do is when we get a no, if it's not written in scientific notation, we're going to have to figure out how to fix it. Using that idea, we'll explore these next steps. So when we write numbers in standard form, it says the absolute value of the exponent right here indicates how many places to move the decimal point. So if the exponent is negative, we're going to move the decimal point to the left. Now, these details right here, this might be a good time to pause the video and write them down, or if you can write quickly as we go through, that's great, but it'll help you to have this reference instead of having to over-process it every time. If the exponent, of course, is positive, we're going to take that decimal point and move it to the right. So we're going to take a look at examples of how we can write numbers in standard form or in scientific notation using these ideas. Negative, left, positive, right. So in example 2, it says write our numbers in standard form. So we have 3.22 times 10 to the negative 4 here. Now, since we have a negative exponent right here, an exponent of -4, remember that that means we're going to move our decimal to the left. These negative exponents really help us rewrite very, very small numbers. So we're going to start with our factor, which is 3.22. And we're going to go ahead and move our decimal that many places, and by that many I mean the absolute value of our exponent in the direction that the sign indicates. So it's a negative, we move it left, so we're going to go ahead and take that decimal and go once, twice, 3 times, 4 times to the left. And now the new decimal point will be right out here in front of everything. Of course, we ended up with a couple gaps here, which we've seen in a lot of scenarios in math. Those always get filled in with zeros. And then we can rewrite in this value, 3.22 times 10 to the -4th, actually as 0 point. And then we have 1, 2, 3 zeros, and here's our 3, 2, 2. And there we have it. We've rewritten our first one in standard form. So again, negative exponents, the decimal moves to the left. And our next part, we'll see one where we move to the right. So part B says write 7.9 times 10 to the 5th in standard form. So we start with our factor. We look at our exponent to know how many times or how many places we are going to move our decimal, and then decide if it's a positive or a negative, which is positive, and what direction that tells me to move, which is of course to the right. And then we go ahead and count 1, 2, 3, 4, and 5, meaning our decimal is now way over here to the right. Add in zeros and any gaps or missing places. 1, 2, 3, 4 of those. And we simply rewrite things carefully. So we have 7, 9, 0, 0, 0, 0. And since the decimal point's on the right, it's not necessary to write it. However, you could if you really wanted to. I'm not going to. I'm going to leave it blank. And of course, make sure commas go in the appropriate places right here. So 7.9 times 10 to the 5th power, that's actually 790,000. And that's actually all we're going to do in this first video. We will follow up in the second video with the rest of the objectives, so make sure that you follow these in order before you jump into too many assignments here. But before we finish this up, I'll go ahead and give you a couple you can try on your own if you want to check your understanding before moving on. So here they are, 4 of them you can try on your own. As always, go ahead and pause the video here, and in a few more moments, you can unpause and check your solutions to see how you're doing. And here you are. Number 1, is it written in scientific notation? No, absolutely not. The issue here, of course, being that the factor is not between 1 and 10. Number 2, 6 times 10 to the 7th power is 60 million. Number 3, 9.9 times 10 to the negative 5th is 0.0000099. And finally, 1.285 times 10 to the 4th power is 12,850. If you have any questions, folks, please reach out to me via email. Otherwise, I will see you next time.